Welcome to our session. My name is Dimitris. I am a front-end developer and an Angular enthusiast.
I'm Abhishek. I work in the dark area of backend and infrastructure, but also I like to experiment with the front-end technologies. I consider myself as jack of all trades, master of none.
As you may have already noticed, our English accent is different, but we both work for eSailors. eSailors is an IT company based in Hamburg, and which provides online lottery software and services. We work along with together more than 150 colleagues, and we are divided in cross-functional product teams. eSailors is actually part of the ZIL network, where more than 24 nationalities are employed.
Before proceeding further, I will quickly go through the topics which we are going to cover today. First, web page rendering, why it is so important to me. I'm just a developer and I love my current technology stack. At the end, our customers will be getting the same output. So what's the real difference? Next, what is server-side and client-side rendering? Server-side rendering is already in the market for last 20 years, and this approach is the oldest one for web page rendering, whereas client-side rendering is relatively new, even though it's been there for last 10 years.
Yeah, a lot of theory.
Don't worry. That's why we have prepared 3 sample prototypes. We would love to go through them, and we want to show you some performance results as well. Lastly, we want to share our learnings from our own journey.
So our own journey started in 2015. Back then, we were assigned to build a new responsive web shop for tip24.com. We were already familiar with server-side applications, so we wanted to keep the initial request optimal. We were also really interested in single-page applications, and we wanted to gain benefit from them. In the end, we just wanted to optimize the user experience. Let's take a look at some useful facts regarding user experience. Researchers have shown that a user would abandon a website if it would take more than 6 seconds to load. Also, each second of delay in page loading time might result in 7% less conversions. As I mentioned before, we were familiar with server-side applications, so the first prototype that we implemented was a server-side application. Usually, when you want to build a server-side application, you need a templating engine like Mustache or Timeleaf or JSTL. In a server-side application, the browser loads pages that are already pre-rendered by the server. Also, we have the luxury to load all of our assets asynchronously. The downsides of this approach are scalability and possible rendering overhead. And what we mean with rendering overhead, let's take a look at an example. So this is the old web shop of Tip24. It's a server-side application. And the load of the page is pretty fast, I would say. But if we navigate to a separate page, we will see that even the navigation bar is being loaded again as well. We wanted to get rid of this rendering overhead. And that's why we started the second prototype with AngularJS. AngularJS is a single-page application framework. A single-page application uses client-side rendering. Everything is being controlled from the JavaScript framework, which in this particular case is Angular. The navigation after the first page load is smoother, because we only load the assets that we need, templates, JS files, or CSS. Unfortunately, we have to wait for our JavaScript framework to be fully loaded during the first page request. And this makes our application non-responsive for a small period of time. Then we thought that maybe we could find a way to combine the advantages of these 2 approaches. So we ended up with a hybrid prototype. The idea was to server-side render the HTML template during the first page load. In the meanwhile, we load Angular, and as soon as it's fully loaded and ready to take action, it takes over the template and the whole functionality. Of course, the complexity was increased, and the implementation became more time-consuming. Yeah, as the time went by, we discovered even more problems. The implementation of some particular pages that contain dynamic data. Take as an example the basket. The basket contains many products with different states. The implementation of this kind of pages became a real pain in the ass. We couldn't avoid flickering, either code duplications, and I have an example for this. So this is the beautiful webshop that we built. If we take a look at the navigation bar, again. So here we will notice that we have the Angular directive, so that Angular can apply the specific route to this specific element, but we also have the href tag, so that the navigation bar is functional even if Angular is not in place. And I also mentioned flickering. So if we go to the basket and we throttle the interconnection, if we refresh the page, we will notice that the value element, the price element, now it says that our basket is empty. If I refresh again, we will see that it's being rendered once now, but it's being re-rendered. And this is the kind of flickering that I told you about. Yeah, last but not least, the back button case. So when a native navigation event is triggered in the browser, it might conflict with the router state of Angular. And this causes unexpected results. Even the whole application might break. The most common case of this scenario is when the user tries to click the back button when Angular is not yet in place. So he refreshes the page, but before Angular is in place and fully loaded, he presses the back button. And this can break your whole application. Yeah, I guess we had enough of theory. Abhi, do you have some code for us?
For sure.
Doesn't say it? Oh, okay.
Yeah, we have prepared a web shop implemented in 3 different ways. The web shop consists of main view, like just a traditional web shop here, and also a detail view, like you get the details. And yeah, and the first prototype, what we are going to show you is a server-side application, which is mainly using a Spring Boot. How many of you are already aware of Spring Boot? Looks like everybody, so I don't need to explain anything. Anyway, so basically this is a Spring Boot applications. We are using a Gradle build as a wrapper here. Here we defined all our dependencies, and these are our packages. Like here we defined all our controllers, homepage controllers, and product controllers. Here we defined all our view objects, like products and extended products. Extended product is basically using product views. And also we defined all our Spring properties in the application YML files. And this is the start point for the Spring Boot application, where basically we are extending Spring Boot servlet initial class. So let's jump into the homepage controller. Basically, we are defining the controller here just to make sure that every request is serving by this controller, which is starting with like the homepage one. So here, basically, we are reading a static JSON file just to mock all the data, since we are not using a database for this project. So we are using this JSON file. Here, basically, we define ID, name, description, price, offers, and pictures. And Yeah, and then we are actually using JSON object mapper just to transform the JSON objects to a product model object. And basically, and after that, we are adding it to the model attribute and then returning the view. But obviously, it's not a good idea to write all your business logic in the controller. It should be somewhere in your service layer. Since we are just using this project for a demo purpose, so we brought it here. Yeah, for view, basically, we use Timeleaf as a template rendering engine. Basically, it is coming to this page, like home page, which is kind of a decorator layout. And here I'm using a Timeleaf attribute, th-include, just to include the partials product list page. Oops. Yeah, basically here we are reading all the domain objects one by one from the model, and then just iterating one by one, and then just printing. Like here we are referring to the product ID for the product detail page, and then just printing the product name using th text, and then showing the product image over here, and also the other details. So let's see how it's actually working. So I start the application. So basically I enable the throttling mode, that's why it's getting more time to get it loaded. And then once I click on the product details, okay, I should, just wanted to show you one thing here. So if I click on the product details, it's actually loading all the asset which is not required by the pages. So this stuff is kind of boring. Dim, you want to show something exciting?
Yeah, a way to handle this is creating a single page application. That's why we did the same implementation in Angular. Yeah, basically it's an old-fashioned Angular 1 application. We have some NPM dependencies and some board dependencies. The main application lies under the app folder. We have some CSS to make it beautiful, some fonts, some images. And yeah, the application is here. Here it's being bootstrapped. We define the Angular components that we need. And also we have used the root provider to handle the roots of the application. We have some controllers. The controllers basically are forwarding the data from the model to the templates. Our model is being handled by a simple service, the product service. Basically, we have two methods here. The getAll method provides the products for the home view, and the getProduct method provides the data for the detailed view. We have our partials. Yeah, the main difference here is that we don't have Timeleaf. We have simple Angular directives. And yeah, again, we're iterating through the model. So let's see it in action. So we have throttled all of the three tabs in the same speed. And as you will notice now, the client-side application takes a lot of time, much more time, until it becomes responsive. On the other hand, if we try to navigate to a details view and we clean the network tab, we will see that we load only what we need. We load only the product detail partial, only the data for this specific product and the images of this specific product. Yeah, so we created also a prototype in which we are trying to combine these two approaches.
Yeah, basically, we took the advantages of server-side rendering and the advantages of client-side rendering and combined together, and we comes up with a hybrid rendering approach. So I would like to go through what's the difference, basically. It's there compared to the other two projects. Basically, here we have two different configurations. One is MVC config. Here, basically, we are loading all the static assets asynchronously, and also we are providing the static asset path here. And the other Other configurations is just we are disabling the cache control just to make sure that the server-side rendering is not using the cache, and every time we are asking for any new request, it's coming from the server itself. And the next one is we introduce a new REST controller, which is partials. This basically request is basically responsible just to deliver the static templates asynchronously. And then, okay. And then we have the layout. Basically, here we still have the time-lapse text over there. And also, I can see some Angular stuff here. Dim, you want to explain?
Yes. So in this server-side application, we also load an Angular application. And we have all of our Angular assets that we need in the end of the body tag, just to make sure that they don't delay the page load. Yeah. So when we want to navigate after the first page load, we go here. Here, we assign the Angular controller with using the ng controller directive. And the interesting part that we combine timelift with Angular comes here. So here, basically, we construct an Angular directive using a timelift attribute that comes from the server-side model. But this works only when Angular is in place, because obviously it's an Angular directive. Does anyone know how we could make it work also when Angular is not in place? No. Okay. Yeah. We would introduce a new code duplication. We would again put an href tag, and this could be functional only as long as Angular is not in place. What else do we have here? I guess nothing really interesting. Yeah, so let's see it in action. So here we load, the first page load, as you can see, it's much faster than the client-side application. But the good thing is that when we try to navigate now, we load only the assets that we need, which is really important in terms of performance.
By the way, Dim, do you really remember why we started using Angular and timelift together?
Yeah, for sure. As you may have noticed already, we just chose timelift in combination with Angular because the timelift attributes are much similar to the Angular directives. I mean, in timelift we have if, in Angular we have ngif, and so on. So yeah, that's just why we chose this combination.
Okay, enough of demo. Next topic is performance. What is performance? It is a key ingredient in keeping audience on your website. As Dimitris mentioned earlier, that customer doesn't want to wait more than 10 seconds in your website. Also, Google uses this index for search result sort order. To measure the speed of our page, we use the free tool from our webpage-test.org. All you have to do, you have to enter the web page URL and also the test locations, and then you are good to go. This test will try to fetch the site 2 times. Also, it will measure how fast the page is delivered for the second time. Before jump into the performance results, let's look into some performance metrics. Time to first byte. According to Wikipedia, time to first byte is a measurement used as an indication of the responsiveness of a web server or other network resource. It measures the duration from the user or client making an HTTP request to the first byte of the page being received by the client browser. Document complete. document complete is the point when all the static page content is loaded. The time here consists of several things. Data is actually sent over to the internet. The speed of this depends on two things, the distance and the bandwidth. The longer the data must travel, the longer it takes. To make the web connections, it requires the server and the client to send few data back and forth. When a connection is open, it is possible to reuse the same connections, so we don't need to establish the same connection. If a web server is in Germany and somebody is trying to access like from United States, then obviously it is going to take longer to send the data back and forth. If somebody is somewhere in France or somewhere in Germany, obviously it is going to take less amount of time. And the other factor is bandwidth. If we need to send a lot of data, it is going to take more time. The bandwidth requirement from the client to the server seldom requires a lot of bandwidth unless you are uploading an images. Server processing. It consists of finding the applications, opening a connections to the database, and extracting the data to show. Then start transmitting the data back. If it is just request an image, then it would not take long time and it will deliver it faster. Of course, we need to get the data back from the server. In this case, we can reuse the existing connection which is already open. Here we recorded the loading process of hybrid rendering. Unfortunately, we don't have the application deployed in any public server now, so we cannot show you real-time demo for our performance results. But we took a screenshot previously. Hopefully you will believe us. If you take a closer look here, the start of render event, which is actually a green vertical line.
It means line, right?
Yeah, that's one. Yeah, so is it only at 5 seconds? And that means the page is actually functional after 5 seconds.
What happens with client-side rendering?
Here, as the rendering starts after more than 12 seconds, that means customer needs to wait more than 12 seconds to start interacting with the website. Let's take a look at a side-by-side comparison of hybrid and client-side prototype. On the left, we are showing the hybrid one, and on the right, we are showing the client-side one. As we can see, the hybrid application renders faster than the client-side application. Let's jump into the conclusions. First question comes to my mind. In the end, should I consider developing a hybrid application? What we saw previously, it is more performant, but on the other hand, obviously you are building something out of the box. So there is no straightforward way to building a hybrid applications. Furthermore, the complexity of the application raises day by day. It's not only server-side rendering anymore, you need to keep in mind the client-side perspective. For example, if you are fixing a bug or writing an integration test case, you need to make sure that covers both scenarios. This applies for quality assurance cycle as well. For some features, you can avoid using hybrid rendering. Let me give you an example. In our current website, customer can purchase lottery tickets. After the purchase is completed, the customer can view the ticket details via ticket history sections. Obviously, this page is protected and the customer needs to log in to access the content. In this case, we use only client-side rendering. Finally, when should we consider to build hybrid apps? When you have too many competitors and better customer experience is a part of your success. Also, if your website is mainly dealing with end customers, you should definitely consider hybrid rendering. In addition to mentioned earlier, if you are serious about organic search results, I believe for most of the e-commerce business, SEO is one of the biggest concerns. When not? If you are having a unique business model and your product is a key success for your business on its own, then obviously you should not take care. And implementation time is critical. If you have a tight schedule and you want to complete the project as soon as possible, in this case, it's better not to consider building hybrid web app. Obviously, technologies are changing day by day. When we started working on our new responsive website, we started with hybrid rendering. Unfortunately, on the same day, Angular released version 2.0 with some interesting features when actually we complete our implementations. Dim, you want to share something on this?
Sure. So, isomorphic applications. During the last year, a new kind of web application showed up. They are called isomorphic. Actually, the term comes from a Greek word, isoformikos. It literally means equal shaped. So these applications basically consist of code that can be executed on both sides, on the client side and on the server side. But there are many frameworks nowadays that provide this implementation, like React, Ember, but I think I love Angular, so I will say a few words regarding Angular 2. In Angular 2, the isomorphic implementation is called Angular Universal. Basically, Node starts rendering HTML templates at specific given routes. And actually, when the pre-rendered template from the server is being loaded from the browser, then pre-boot facilitates the transition to the client view. And how this is being done? So here, the server-side template is loaded. Pre-boot comes along as inline JavaScript, and it starts recording the user activity. And as soon as the client view is ready, it replays silently the user activity. So this is the way that Angular Universal wants to solve this issue.
Cool. Here are the repositories of the prototype which we shown previously, and also official Angular Universal repository. Thank you for your attentions. I guess we have enough time for questions.
No questions.
We have one question left, but I think it's... We have every goddamn time. We have one question from the app. It sort of plays into the last part, and it goes, in your comparison, have you considered using Node.js with HTML service workers as a prototype similar to progressive web app suggestion?
Yes, and I guess that this question came before we proceeded to the last slide with Angular Universal, and that's why we're strongly considering the last month to migrate to Angular 2.
My follow-up on that personally would be, like, does it use service workers? Like, it doesn't, right?
Our approach?
No, the Angular 2 server-side rendering, does it use service workers?
Yes.
Oh, it does.
Yes.
I did not know that. Cool, thank you. Other questions from the audience right now? Yep.
So, are you using this in production? When I saw you on your website, was on the beta subdomain?
Yeah, it used to be in beta, but since 2 months, it's already live as well.
Okay, so you're driving a hybrid approach to...
Exactly, it's production currently. Yeah, and it works quite fine.
the overview pages are all server-side rendered, and
Yes.
retail pages are rendered using hybrid approach.
Yes, actually, protected pages are all rendered only client-side. And also, we mostly server-side rendered SEO important pages.
Okay.
Yeah.
Yeah, okay, that makes sense. Thank you.
Any more questions? No.
No.
Well, then thank you once again to the presenters.